Welcome back everyone to the Betamax Rebel Outpost. So this SL-HF1000 just came to me from a customer. This is an SL-HF1000 from 1986. It's in very nice condition. It was sold to him as a new old stock machine, and he just wanted me to take a look at it and see exactly what it needs, what the condition really is. He says it's having trouble loading a tape. So I'm going to take a look at that here in a minute and figure out what's going on with the loading and see how it responds to all of the other functions and features. And I can tell right away it's not new old stock. If it was new old stock, this the top edge of the front panel wouldn't be as shiny. And there's also some nicks and other rub marks in it. But this should be a dull finish, not a shiny finish. So that's kind of my first red flag on this machine, that it's not new old stock. So before I take the top cover off, I also noticed this on the bottom cover. We have these stickers, and these stickers are definitely not original. This is not what comes from the factory. Rear panel looks very clean. No missing screws, so that's kind of nice. Sometimes one of these screws is missing from somebody digging into it, not putting it back together correctly, or putting in an incorrect screw. I'm going to go ahead now and take the top cover off. Okay, first thing I see right here, these two capacitors have been replaced. These two large filter caps, 10,000 microfarad, 25 volt. Those are not original. Original cap should be ELNA and lower profile style capacitors. Now that old T-coil post has busted off long ago, and somebody's inserted the spring down into the slot in the floor, which is fine. That's a legitimate repair, and it's very common in the 711B2s. Okay, the front panel retaining. So we got a little crack here in the front panel retaining arm, the center. Okay, and another interesting point about this HF1000 that I noticed right away is the upper drum looks really nice. It doesn't have that. It has a little bit of a wear mark, but it's really not bad. I need something better to point with. I'm going to use one of these. Right here, you will often see a very large, polished down wear mark. And these 1000s, I mean, these got a lot of use. So this one obviously has been spared. I see a little bit of a wear mark. It's kind of hard to tell on the camera here. Another thing we can check for too is any strange scraping sounds coming from the drum, which can be associated with a bearing that's gone bad, or with the rotary transformer coils. The glue rots and they start coming loose, and of course the one in the top half, you know, from gravity is going to hang down and start shorting out with the bottom rotary transformer coils. So I'm going to just check to see if there's any strange noises. And it sounds perfectly quiet. No strange scraping noises and no strange bearing noises, so I'm happy with that. Let's see what it does when you power it on. And the solenoid sounds pretty strong. The pinch solenoid right here engages when you press the power on, and sometimes it goes weak. Get closer there. As it ages, it becomes kind of weak, and it won't engage at all at some point. Eventually it just will not engage. But that sounds very strong. I'm going to take it out anyway and give it a good cleaning, because these solenoids do tend up to get a lot of dirt buildup. That sounds a little soft releasing it. I think it could be better. And with a weak solenoid, what ends up happening is sometimes they'll snap in, but when you release the power button, when you go to turn the system off, sometimes the solenoid just stays in place where it's at, like this. It'll just stay there, and then when you go to load a tape, it'll start threading or doing weird shit, and you don't need that. It's got to come all the way out to here, and sometimes they don't. Sometimes it's kind of weak and it comes out halfway or just a little bit or nothing at all. So we can get in here and take this solenoid plunger out and give it a really good cleaning and inspection, and usually that solves the problem. Okay, let's see how it does when we go to load a tape. So, okay, yeah, my customer mentioned that it's having this problem loading a tape. Sometimes it loads, sometimes it doesn't. There it goes. This is fast forward. This is rewind. And this is playback. And that drum sounds very quiet. I'm going to go ahead and eject now. Okay, so basic playback functions appear to be working just fine. I'm going to dig into it more and see what I can find. We'll go ahead and take the bottom cover off first. Do not impact this area underneath this. What the f? Oh, that is really strange. There is a piece of bubble wrap. What's the point of that? You just find the weirdest things in these old VCRs. Actually, I'm going to go ahead and take off this front cover first before I dig any further. Just to get this out of the way. Okay. So far everything looks pretty clean. No broken parts. Go ahead and take a look at what's going on under the servo board. Okay, that's good. So far there's no big surprises anywhere. Looks pretty intact. Let's remove this shield here momentarily. Okay, that's good. No surprise there. No cheesy replacement capacitors that are 3 times the size of the originals. That's good. So let's see what's down here. Okay, so the Hall effect sensor right there. That's got the old glue for sure. That looks like crap. That's got to come out. Yes, the Hall effect sensor glue here on the pins. It's not shorting yet, but it will. So I'm going to go ahead and scrape all that stuff out and secure it back down for my testing. And if it blinks out on me, then I'll go ahead and replace it. Okay, and pulling up the video board, I see there's been some rework done to this audio interface board down here. This is the input-output board IO-4. And I also noticed this right here. Somebody's added these 2 wires right here off these 2 legs of the resistors, R434 and R432. So that's the right channel output and left channel. So right channel, left channel output have been hardwired from the output resistors to the jack terminals. And pulling up the tuner board, and here is the AU21 board. This is the hi-fi processing circuit board. And it looks pretty much untouched. I don't see any modifications on this board. No change to capacitors. No surprises. So I like that. Okay, so now I'm going to get into the mechanism. I'm going to start with the loading issue that's happening. It's kind of intermittent. There we go. Okay, just come out like so. There we go. Now, I don't think the camera can get this, but there is a slight wear mark on that bottom edge for the CTL track. There's a little bit of an oxide mark on there. I'm going to clean it up, and I'm just going to leave it alone for now and just clean the tape path up really nice. I'm not seeing a lot of heavy wear marks anywhere else, so that's a good thing. Here's a look at the tray loader. This is the carriage loader assembly. In HF1000, the loading switch is secured down with a Phillips head screw. Looks like somebody's been in this before. This lube right here has been added. That's not original Sony carriage loader lubrication. Yeah, and these contacts here for the load switch, these are completely filthy. These are barely making continuity. You could definitely use a cleaning up. The inside doesn't look too bad. It's actually pretty clean in there. No broken pieces. Okay, so now I'm going to clean up the switch. This is the loading switch, and it's known to fail quite a lot. And all that needs to be done in most cases is just clean the contacts. Okay, not done yet. These leads to where the wires are soldered to, these rot, and I've seen these come separated. And it happened once when I sent a machine back to a customer. I thought I had fixed this switch. All it needed was a good cleaning here on the contacts, and I snapped it back in and I sent it on its way. And when he got it, it started acting up again, so I took it back and I found out that there was some separation happening right here. One of these was fully separated as the solder had rotted off this kind of material here. So it's best to inspect them, and while I'm here, I'm going to go ahead and reflow this one anyway. There we go. Okay. So, okay, this is the only thing that goes wrong with the 711B2 loaders. It's usually this tooth right here breaks off, and then you have a situation where the loader is all out of alignment and it won't load the tape properly. So it's a two-piece unit here. It just comes off like that, has a spring in there. And what I like to do is I just add a little bit of reinforcement here with some steel. Just make this steel ring, and I basically press it. I make a small little groove right here in the edge of this wall so it can fit in tightly. just as this end naturally fits in tightly with how this plastic has been formed and shaped. And it just acts as a retaining ring to add a little bit more strength to the inner wall of these teeth. Because, like I said, when you find these, they're usually broken like right here. This tooth snaps off, and it just happens to be in the thinnest section of the plastic. It's very simple. All you have to do is mate up the holes. As you can see, it goes all the way through. And this one will line up right here. This one lines up right here. I just need to get into this gear block assembly really quick and find out what's going on with that solenoid plunger. Whoops. Okay. Well, that's very interesting. That is this is one of my modifications. That's very strange. Unless somebody just got the same idea as me, which that could very well be, because I've been selling these on eBay for a long time and I advertise this modification once in a while. I go ahead and pull off the old black toothed gear right here and press on a brass gear. It's kind of a tough mod because the gear itself, the hole diameter is too small for the original shaft, so I do have to put it in a drill press and just bore it out slightly so I can press the shaft over the gear. But I guess my idea started spreading on, or someone had the exact same idea and didn't see my idea. I don't know. It's very cool though that they did that. Oh, and they did it very nicely too. There's absolutely no wobble at all. They got it perfectly straight on there. Okay, moving on. I'll take out this gear plate. See how that's looking. Okay, it's got the typical wear. The gear itself is always scraping along the floor here and contributes to noise from the mechanism. I really wish the gear would not make contact. I've often wondered if I could put a spacer in here or something to prevent it from making contact, and that would help quiet things down. But apart from that, the mechanism does sound pretty quiet. But I know I can make it quieter. The gears also wear out. The nylon gears inside the gearbox itself, when they start wearing out, there's no adjustment that could be made to quiet them up. The only way to do it is by replacing the gearbox itself with something brand new. Which I think somebody out there is making 3D replacements for some of these parts. 3D printed replacements. Get this spring out of the way. Okay. Yeah, and that's got some kind of, looks like somebody's put some kind of oil on here. There shouldn't be any oil on this at all. This should be completely dry. So that's going to have to get cleaned up. And here's a better look at the upper drum condition. It looks very clean. Now I'll have a look at the reel table board assembly. Just a quick look at some of these solenoids. You can see in there, it's awfully dirty in there. There we go. So these can definitely use a cleanup. Right now, more importantly, the this brushless motor here, this pancake motor, this gap right here, I'm a little concerned with the gap between the magnet and the stator coils down here. It looks awfully thin right there. No good. If you hear that just by doing this, then this wear has happened in this little retainer bearing. That plastic has worn down, and there are various ways of doing it. I'm gonna just add a spacer on the inside. I think that one's a little bit bigger. This is the thin one that I sanded down. I think I'll try this one first. Since that's the thinnest one. Okay, as you can see now, I've got it down to 0.3 millimeters. So hopefully that will be the right size to put in. Just have to try it. Kinda gotta put this in sideways so it doesn't get caught in there. Okay, and it is at the very bottom. Yes. And that looks a lot better already. Like more heavy carbon buildup on the brake solenoid here. So that's going to need a good cleanup. I'm going to have to check the switch contacts and the mode switch here. Okay, there we go. And I gave the axle some oil. This was in desperate need of oil. Yeah, it's pretty filthy. I think based on the condition of this drum, I'm not even going to take it off. It looks okay. Just going to give it a little Scotch-Brite. I'm going to use the Mr. Beta approach, using the Scotch-Brite pads to just slightly clean up the upper drum entrance side. I think that's all it needs. Okay, time to take a look at this pinch solenoid. I see it's got a lot of carbon buildup inside and hasn't been serviced, so we'll see how it cleans up. Alright, let's have a quick look at this capstan shaft. It still feels pretty good. I don't feel a hard nick or lip right here where there's tape travel. So I'm just going to give that a good cleaning. It does have a bit of a shiny spot, of course. Go ahead and throw in the pinch solenoid. Just a touch. Doesn't have to be a lot at all. Okay, and now we can fit the solenoid. There we go. Make sure that's free. Just cleaned that up just now with just a Q-tip, some alcohol, and some rubber renew. Wasn't that bad at all. I made this tool specifically for getting into this section of the drum, specifically to get up under the edge of this drum disc magnet. Mr. Beta, if you're out there watching, this really works a lot better than other methods I've tried. This just makes it much safer instead of trying to use some large tools or go. Okay, that's all it needs, just a little dab. And I'm just going to let that dry overnight. Very light drop of oil, since we're here anyway. This is just reinforcement for some of these plastic frame rails. Just some added reinforcement to keep it well together for many more years to come. They tend to become a little fragile and they start breaking apart until large sections start coming undone. So to prevent that, I've just added some of this reinforcement here. Here's a look at the RF head amp. All of the capacitors have been tested and found to be in working condition. And now having a look at the power supply, this is the first thing I noticed when disassembling the regulator from the heatsink. If you look down here at the heatsink compound, it's wet. So I'm guessing this regulator is relatively new, and it's been replaced quite recently. So taking a look underneath, and I was right, this regulator has been replaced, and whoever replaced it did some really shoddy workmanship in soldering in the new one. Some pins look like they can use some reflowing. Didn't quite get enough solder on some of them, and didn't bother cleaning up any of the flux residue. So it looks like we're dealing with some pretty shitty capacitors as well. Some of these are not even registering on my ESR meter here. They're just completely open. That one's okay. It's functioning. So some are functioning and some are completely dead. That one can probably use replacing, as well as these three down here, which are, looks like a couple 22 microfarads. Okay, so the steel frame has been cleaned. Pins of the IC voltage regulator have been cleaned. And I managed to also replace, there's also some brand new capacitors in here. New capacitors where needed. I didn't replace every single one, and these large ones here, they're in very good condition. And here's the AU21 Hi-Fi processing board. I just have it out so it's easier to check the condition of all the electrolyte capacitors and see what kind of condition they're in. And here's a look at the input-output board, IO4. And I just took it out so I can test all the capacitors, just like the other board. And see what's going on here as to why the last technician decided to bypass the traces and add these jumps on the output for left and right channel audio out. And from what I can see, So from what I can see is someone has come in here and actually physically chopped out the trace from the output here at the resistor R34 and R434 and R442. They have come in here and actually chopped out the trace leading over to the RCA audio output jack. And I can't understand why somebody would do this. It doesn't appear that there was an actual fracture or a crack from damages, but for some reason they decided that it was important to chop the trace out and add a wire, maybe in anticipation that there would be a problem in the future. I don't know, but that's very strange. That's something that I would just never consider doing. And this is what I came up with for the correction. It's a much nicer appearance. The wires are flat to the board, out of the way, and less chance of a breakage happening. And here is the video processing board V118, and all the capacitors test good, all the inductors are good. No surprises. I'm going to go ahead and check some of the DC levels here at the power supply before we even get started. Alright, there we go. That will work. So we'll start with a switch 12 volt check on pin 1 of CN2. Oh, okay. And it's right about there. And it is 12.08. Switch 9 volt check, pin 2 of CN2. That's right here. 8.98, close enough. That looks good. Unswitched 5 volt check, pin 3 CN2. That's right here. 4.959, close enough. Pin 2 CN4 is 12. There's pin 2, 12, and pin 3 should be negative 12. Okay, that looks good. And then you have pin 1 of CN5 is 45. Pin 1 CN5, it's down here. Okay, 48. That looks good. Plus or minus 5 volts. So that's correct. And then pin 1 of CN1 minus 26. Minus 29. And it says minus 26 plus or minus 3 volts. So that looks good. And then pin 2 and 3 on the AC scale. Pin 2 and 3 AC 3.8 volt check. Pin 2 and 3 is CN1. .7. Okay, so all the DC levels look good. Okay, well, let's see how it does now that it's back together. That sounded good. Just fast forward. Stop. Rewind. Stop. Playback. Eject. Okay, now let's see how it does with the tape. Seated firmly. Here's fast forward. Rewind. Fast forward. play back. And here's pause. Well, that's interesting. The machine just went into shutdown. Let's try a different tape. Misload. Yeah, that motor should be running a little faster and sharper than that. But these nylon gears, when they wear out, there's really nothing you can do about the sluggishness. And if we look at the take-up reel, it seems to be working fine. Here's pause. Playback. Okay, yeah. We've definitely got some take-up reel problems. So it takes very little effort to stop this take-up reel, so I can tell the torque on this reel motor is pretty much shot. Okay, so I just finished swapping out the reel board from my parts HF1000 back over here into my customer's HF1000. So this has the old reel table for my customer's 1000, and it has a weak reel torque. Once the torque goes weak on these boards, there's only one option, and that's to just get it replaced. Because the carriage loader was also a problem, I went ahead and replaced it with the one for my parts HF1000. The tape wasn't going in straight enough. It seemed kind of lumpy, like there could be a warp in the plastic. So I just put it to the side for now and replaced it with the one for my parts HF1000. But I did transfer the reinforced gear that I made into this loader, so that's going to stay. I think that's a lot better. It goes in straighter. It doesn't seem to clunk about as it's loading. Okay, so we'll hit play, and now when we go into pause mode, the reel stops, of course, and when we release pause, it goes straight back into action without any tape slack occurring and without a forward torque error. Okay, so that's solved, but I still don't really care for this threading motor. It just sounds tired. Hear that? It just sounds kind of weak, so I think I'm going to go ahead and replace that too with the one from my parts HF1000 that responds much quicker and faster. It's sharper sounding. I mean, this one still works, but I just think it's getting tired now, and it's just going to get worse and worse from here on. And it's this gray pair right here. Just pull the whole thing up. A little bit of a trick, but not that bad. There we go. And this one is going to work a lot better. The plastic is still very white. It's very clean. It still has the original black gear. That's looking a little bit dry. Hasn't got that that smooth glossy finish anymore, so I think I'm going to go ahead and replace that with the one over here in the customer unit, the one that's modified, the little brass gear. That can go in the place of this one. Yeah, and this one is much more discolored. It's very yellowed, and that's why the gears sound the way they do. It's just getting tired. This one has fewer hours on it, it looks like, and the other machine, it has different problems, so it doesn't matter to take this out. So it will benefit another machine greatly. Let me get this out. Go. There it is. Oops. Now Sony likes to curl this around this little clip retainer here. I just put it in like that. There's no reason to keep coiling it around. Okay, let's see how it responds now. I mean, it's not brand new, but it's a lot better than the other one. I'm just going to test the back tension and forward torque. And the spec should be 45 grams a centimeter. It should be 45. This one looks like it's 40. That does fall within spec, plus or minus 4. Okay, I'm going to now put the unit in record mode and check the forward torque, which should be, I believe, between 45 and 90 is the correct specification. And this one looks like it's coming in at 60, so that's just fine. A little bit over 60. Let's see how the picture looks. Looks very clean, very stable. This is the capstan duty cycle, capstan DC bias adjustment. There should be a 50% duty, so it's 50% on, 50% off, and try to make that as even as possible. That's about as close as it's going to get. Okay, so the specification for center tracking calls for the timing between record CTL 30 Hertz pulse to the time of where the ramp ends. The tracking ramp that's produced by the sync gate should be 860 microseconds. $769. We actually want it right about there. Right there actually is perfect.
Ejection seats would be the only means of getting away from an explosion on the way up. but escape would bring a rough ride, perhaps broken bones.
There's black picture.
Tests from
100%
high-flying
black.
aeroplanes rehearsed escape from a tumbling spacecraft. On a
Data screen.
There were no limits to the variety of training which eliminated aspiring cosmonauts.